Which reaction would be expected to have the largest Arrhenius or pre-exponential factor A at constant temperature? So I have written Arrhenius equation. K is equal to A, E minus EA over RT. A is called Arrhenius factor or pre-exponential factor. EA is activation energy, R is a gas constant, T is temperature. A deals with frequency of collisions and the proper orientation of the molecules. And A depends on three things. Number one, the complexity of the reaction mechanism. Number two, the number of molecules involved. And number three, the physical states of the reactant. So in this question, what we're looking for, which reaction can take place easily? If a reaction can take place easily, that means the Arrhenius factor A will be the largest. So if we look at option A, we have a hydrogen gas plus iodine gas forming HI as a gas. So two atoms, they react together. So this reaction is simple, straightforward. So atomic collisions are very simple and the molecule do not need any significant orientation, and hence I will go with A as the answer. If we look at B, looks like simple reaction, but the orientation is slightly complicated than A because the old bonds need to break, and H2 and I2. And similarly in C, yes, we have two molecules of HCl, so the bonds need to break, and similarly in D. So what we're looking for here is simple orientation, less steric hindrance, hence A is the correct answer. So the reaction A has the largest pre-exponential factor because it involves simple collisions between atomic gases. There's a minimum complexity in a molecular orientation, and also the atoms, they are in a gas physical state. So the reaction dynamics favor a high frequency of successful collision. Which reactions involve the transfer of proton? So option 1, hydrochloric acid react with magnesium solid forming magnesium chloride plus hydrogen gas. There is no proton involved here. We can see H plus get reduced to H2, and this is an example of a metal react with acid to form salt and hydrogen, so there's no proton transfer takes place here. Number 2, hydrochloric acid react with magnesium oxide forming magnesium chloride plus H2O. So that is an example of neutralization, and we can see there is a transfer of proton. So H plus react with oxide ion forming water. So number 2 is right. Number 3, so magnesium carbonate reacting with hydrochloric acid forming magnesium chloride, water and carbon dioxide. This is an example of neutralization reaction as well. There is a transfer of proton. It react with carbonate initially and form carbonic acid, H2CO3, and then that break down into water and carbon dioxide gas. So there is a transfer of protons in 3 as well. So 2 and 3 is the correct statement. So let's look. We have C as the correct answer. So once we know statement 1 is not right, we can see A, B, and D, they have 1. So hence they are not the right option. So C is the correct. The indicators, H indicator is used in an acid-base titration. Which statements are correct? So indicators, they have one color in undissociated form and they have another color in dissociated form. In given example, undissociated form has color A and dissociated form has a color B. So let's start reading these statements. Statement number 1. In a strongly alkaline solution, color B is observed. That statement is correct because equilibrium will shift to the right and I and G minus concentration will be bigger, hence we will observe color B. So the first statement is right. Statement number 2. Color A is observed when H indicator molar concentration is smaller than I ND minus molar concentration? No, that statement is wrong. Color A will be observed if H indicator, so undissociated molar concentration, bigger than the dissociated IND minus concentration, then color A will be observed. But in given statement, color B should be observed, not A, because HIND molar concentration is smaller than IND minus concentration. So statement 2 is wrong. Statement 3, IND molar concentration approximately equals HIND molar concentration at the end point. That statement is right. So at end point, HIND molar concentration approximately equals to IND minus molar concentration. And statement 3 is right. Let's go through the options. We are looking for 1 and 3, which is B. So B is the correct answer. The overall reaction occurring at the electrodes of rechargeable metal hydride battery can be summarized as, which statement is correct? The oxidation state of nickel doesn't change, so let's assign the oxidation state. MH, we have a metal hydride, so hydrogen will be -1 here and metal will be +1. And the product side, metal will be 0. And OH, so we have -1, -1, and nickel is +2 here. We have -1, -2, so nickel is +3 here. So oxidation state of nickel doesn't change. No, it does change. So that is not the option. M is oxidized by loss of hydrogen. No, we can see +1 to 0. So metal has reduced. So B is not the answer. See, the oxidation state of one hydrogen atom changes from -1 to +1. So yes, we can see -1 on reactant side. And on the product side, it will be +1. So if we deal with OH minus, oxygen will be -2, hydrogen will be +1, because there's overall charge of -1. Hence, C is the correct answer. Let's look at D. The oxidation state of one oxygen atom changes from -1 to -2. No, oxygen is still a -2 on both sides. In a redox titration, manganese 7 ions are reduced to manganese 2 ions, and iron 2 ions are oxidized to iron 3 ions. What volume in centimeter cube of 0.1 mole per dm cube MnO4 is required to reach the equivalence point in the titration of 20 centimeter cube of 0.1 mole per dm cube Fe2+? To answer this question, we need to write down the overall chemical equation. So let's start first with MnO4. So MnO4 gets reduced to Mn2+. Let's balance this half equation. So we have 4 oxygen on the left hand side, so I will add 4 water molecules on the right hand side. Because this reaction taken place under acidic conditions, so we have 8 hydrogen on the product side, so I will add 8 protons on left hand side. Next, we need to balance the charge by adding electrons. So charge on right hand side is 2+. So if I add 5 electrons on left hand side, then I will have a charge of 2+. So this half is balanced. Let's deal with the oxidation half. So where we have iron 2+ oxidized to iron 3+. Iron is balanced. We need to balance the charge on product side is 3+, and charge on reactant side is 2+. Because this is oxidation, so we need to add electron on the product side. So if we add 1 electron on the product side, then charge is imbalanced on both sides now. Reduction half needs 5 electrons, oxidation half is giving 1 electron. So if we multiply the second equation with 5, and then we can add them together, and electron, they will cancel with each other. So we will have 5 Fe2+, plus we will have MnO4-, plus we will have 8H+, On the product side, we will have Mn2 plus we will have 5Fe3 plus we will have 4H2O. So if you look at the ratio between IN2 plus and MnO4 is 5:1. What volume of 0.1 mole per dm cube MnO4 is required? So because the concentration of Fe2 plus and MnO4 minus is the same, volume of ion is 20 divided by 5, that will give me 4. So we need 4 centimeter cube of MnO4 to reach the equivalence point in the titration. Hence B is the correct answer. Which statements explain the following reaction occurs in upper atmosphere? CFC chlorofluorocarbon compounds break down to produce chlorine radicals, but usually not fluorine radical. So that's just carbon fluorine bond is the strongest bond and it has a higher bond enthalpy. So let's narrow down our choices. B says CF bond is stronger than CCl, yes. And D says CF bond is stronger than CCl. You can get rid of A and C, so that leaves us between B and D. And this reaction proceeds through free radical substitution. Let's go to the second part. So a single chlorine radical breaks down many ozone molecules. In B, it says chain termination steps cause chlorine radical to form chlorine molecules. No, that is the last step and where the reaction terminates. And let's go to D now. So the chain propagation step produce more radical. Yes, during propagation, more Cl free radical they are produced in the second step of propagation, and this reaction continue and cause ozone depletion. Hence, D is the correct answer. Which term cannot characterize ammonia NH3? Let's quickly draw the Lewis structure of ammonia NH3. So we have a lone pair on nitrogen, and a lone pair donor is called a ligand. It can form a coordinate covalent bond with a central metal ion. C is correct. D, nucleophile. Ammonia can act as a nucleophile, so D is correct as well. But we're looking for a term cannot characterize ammonia. A is Lewis acid. So Lewis acid is electron pair acceptor, which seems not right because ammonia cannot accept a pair of electron because nitrogen always follow the octet rule. Hence, A is the correct answer. Option B, Bronson and Laurie acid, might be possible. If it's, then we can have NH2 minus the species produced plus H plus. So A is the correct answer. Which ion is a better leaving group in a nucleophilic substitution reactions? So we have carbon fluorine, we have carbon chlorine, we have carbon bromine, and we have carbon iodine bonds. Bonds break hydrolytically, and a pair of electrons will transfer to halogen atom, and they leave as a F minus, Cl minus, Br minus, and I minus. Carbon fluorine bond is the strongest bond because it has the highest bond enthalpy. So carbon fluorine is the strongest bond, and carbon iodine is the weakest bond. Because it has a lowest bond enthalpy. Hence, iodide will be a better leaving group. Hence, D is the correct answer. Which statement is correct when 2-chloro-2-methyl pentane reacts with water to form 2-methyl pentanetol? So we have a haloalkane given, and haloalkanes, they undergoes SN reactions, nucleophilic substitution. Primary haloalkane, they undergoes SN2, and tertiary haloalkanes, they undergoes SN1. Let's write down the formula of the haloalkane and see what type of haloalkane is given. So CH3, CH2, CH2, that C has a Cl, CH3, and then CH3. The given haloalkane is tertiary, tertiary. So tertiary hill volcano, they undergoes SN1. So SN1 unimolecular. So, and there's a two-step process. In the first step, a carbocation is formed, and this bond will break, and Cl will leave, and we'll end up with a carbocation. Ca3, CH2, CH2, C plus Ca3, and Ca3. A carbon which has a positive charge is called a carbocation, so that is intermediate. And in the second step, nucleophile will attack. A nucleophile can attack that carbon which has a positive charge. So let's go through these statements. Water acts as a nucleophile and attack the chlorine atom. No, that's wrong. Water will act as a nucleophile. It should attack the carbon with a positive charge. Reaction occurs in a single step. No, this is SN1 and takes place in two steps. First step is a rate determining step and is a slower step. Second step is the fast step. C, a carbocation intermediate is formed. That is correct. Option D, homolytic bond fission occurs. No. If homolytic bond fission takes place, then we should have free radicals, not ions. Hence the correct option is C, which illustrates the correct intermediate formed in the nitration of benzene by NO2+. Benzene undergoes electrophilic substitution reactions, and in the first step, nitronium ion NO2+ react with benzene and an intermediate is formed. So the first step involves attack by the electrophile NO2+. So a pair of electrons from the pi system of the delocalized electron is donated to electrophile. So benzene is acting as a Lewis base and NO2+ is acting as a Lewis acid. So what we're looking for here, a carbocation. Let's narrow down our choices. So B and D we can eliminate straight away. And we're looking for a ruptured ring. So benzene ring will ruptured and a positive charge. Hence A is the correct answer.